Hello guys, in this video I am going to explain about two things. The first one, what is resistance, and the next thing, what is the relationship between resistance and resistivity. Now in my previous classes I have explained about the voltage, current and flow of free electrons, right? Yes. Now if I take a simple circuit here, now I am taking a simple circuit where the voltage source is connected and we have a load. The load may be electric bulb or fan or motor, whatever it is. Now we have a connecting wires. Now what happened, as I have connected a voltage source, this voltage source will push, that will cause the flow of electrons in the circuit. That is nothing but what? Current. So because of this voltage source, some current is flowing in the circuit. Now we have derived that voltage is directly proportional to current. If any circuit, if the voltage is equal to 0, then the current will be 0 in that particular circuit. If you increase the voltage, what happened? The current is also increasing. Clear? These are the things we have discussed in our previous classes, right? Okay. Now what is the meaning of resistance? Resistance is nothing but it will resist the flow of electrons in the circuit. Now see, what is the symbol of resistance? What is the symbol of resistor here? The resistor is having two terminals, terminal A and terminal B. So it is indicated by R. Okay. Now what this resistor will do? Resistor will resist the flow of electrons in the circuit. Now the same circuit I am going to add the resistance here. These are the connecting wires. So here I have connected a resistor before load. Now see, as I am using a voltage source, what happened? Some current is flowing in the circuit. Now here as I am using a resistor, what this resistor will do? It will resist the flow of electrons. Now current is nothing but what? Free electrons are traveling through the connecting wires. Yes or no? Now if you see the inside of the resistor, suppose here the inside of the resistor, so the resistor is having two terminals A and B, like here. Okay, the inside of the resistor we are having so many atoms like this. Okay, so many atoms like this. So as I have connected a voltage source, some free electrons are traveling through the connecting wire. That means let us assume that we have free electrons are traveling from terminal A to terminal B. This is terminal A and terminal B. So what happens when these free electrons are traveling from A to B? So whenever I have connected a voltage source, this free electrons has some energy. Okay, this free electrons has some energy. Now whenever these free electrons are traveling, so it has some chances, okay, or it has some possibilities that these free electrons will hit this particular atom. Whenever these free electrons hit the atom, or whenever it happens the collision, the electrons, free electrons will lose some of the energy, this how the resistor will oppose the flow of electrons. Now the loss of energy, okay, the loss of energy is completely depends on the type of material you used to prepare what? Resistor. Now here you can prepare the resistor by using different material. For example, you can prepare the resistor by using metal films, for example like copper, aluminum or anything, or so and so on. Or you can prepare by using metal oxides like titanium dioxide or tin dioxide and so on, or by using carbon films or carbon composite. Okay, carbon composite. So these are the materials we are using to prepare what? The resistor. Clear? I hope you understood what is meant by resistance. Resistance is nothing but what? It will stop the flow of electrons in the circuit. So we are using resistor to do that. Clear? Now you need to understand the relationship between what? Resistance and resistivity. Now here I am taking a resistor. Let us consider this is the resistor is having what? Some cross sectional area. So this is what? A cross sectional area, and it is having what? Some length L. Now let us consider we have what? 5 free electrons wants to travel from terminal A to terminal B. Clear. Now, as I said, this resistor inside we are having what? So many atoms. Now it is difficult to travel from A to B as we have so many free atoms. Let us consider this is what length L. So length L equal to 1 meter. Now I am taking another resistor, so the cross sectional area is same, but whereas the length is doubled as compared to example 1. So here length equal to 2 meter. Now what happened? These 5 electrons want to travel in the same material from A to B. So what happened? Is it easy or difficult? Of course, whenever the length becomes doubled or increased, the flow of electrons from A to B becomes difficult. Therefore, the resistance is what? Directly proportional to what? Length. So if the length is increasing, the resistance is increasing. If resistance is increasing, it will restrict the flow of electrons, right? So the length is directly proportional to what? Resistance. Okay, this is what our equation 1. Now what happened? So I am taking another material. So the length is what? 1, but whereas the cross sectional area is what? Higher. So here what happened? So is it easy to flow these 5 electrons compared to case 1 and case 2? Of course, it is very easy to travel these 5 electrons from A to B. Therefore, from this assumption, you can write the resistance is inversely proportional to what? Cross sectional area. This is our equation 2. If the more the length, more the resistance, and if the more the cross sectional area, less the resistance. So if cross sectional area is increasing, what happened? The resistance will decrease it. Okay, clear. Now from equation 1 and equation 2, you can write that resistance is directly proportional to what? Length by area. Clear. So if I remove this cross directly proportional, I will get what? One constant there, that is what? Rho. L by A. So here rho indicates what? Rho is nothing but the resistivity. Okay, rho is nothing but the resistivity, and here R is nothing but the resistance. Okay, now we want to derive the relationship between resistance and resistivity. So here see, so as we want to derive the relation between these two, therefore here I am writing the resistivity equal to resistance into what? A by L. Yes or no? Resistivity equal to R into A by L. This is the relationship between the resistance and resistivity. Any equation you can use it. Okay. Now here, suppose if the length is increasing, what happened? The resistance will increase. If the cross sectional area is increasing, the resistance will decrease, right? Then what happened to the resistivity? Okay, the resistivity depends on length and cross sectional area? No, it completely depends on the type of material you are using. So in my previous slide I told you that we are using metal film or metal oxide or carbon and carbon composite to prepare what? The resistor. So here the resistivity depends on what? The type of material you are using. Clear. Now see here, one assumption that if the area, cross sectional area is 1 unit, let us assume that cross sectional area is 1 unit and length is also what? 1 unit. Therefore if you submit 1 unit by 1 unit, what happened? The resistivity is directly the resistivity is what? Equal to resistance. So this is the equation when cross sectional area and length is equal to 1 unit. For example, here I just want to explain that I am using a copper to prepare what? The resistance. Okay, clear. This is what our resistance. Now what I am doing, the same resistance, I am not changing the material I used. The length I am increasing into 2 times. For example, here this is what? 1 meter. Now the same material I am increasing what? Length equal to 2 meter. Now my question is, so if I increase length by 2 times with the same material, what factor will affect either resistance or resistivity? See, as I said, the resistivity completely depends on what? The type of material you used. But whereas for the resistance depends on what? The length and area. So when you increase the length by 2 times, of course the resistance will increase. So if resistance is increasing, it will resist the flow of electrons more. Clear? Now you need to understand about units. Now what are the units for resistance? So for resistance, units are what? Ohm. So this is what the Greek symbol you can represent ohm. Now what are the units for resistivity? So the resistivity equal to what? Resistance into area by length. So you know units for resistance is what? Ohm. And what are the units for cross sectional area? Meter square. And what are the units for length? Meter. So if you cancel this one, therefore ohm meter is what? The units for what? Resistivity. And what are the units for resistance? Ohm. Clear? Now there is a formula. We have Ohm's law, V equal to IR, and we will discuss about Ohm's law later. Therefore here from this you can write resistance equal to what? V by I. V by I. So what are the units for resistance? You can represent by ohm. Now you need to understand what exactly meant by this equation. So here if I take a resistor here, and it is having two terminals A and B. Now let us consider 1 ohm is the resistance of this material. Okay, resistance of this particular material. So what 1 ohm indicates? Okay, so 1 ohm indicates that when 1 ampere of current is flowing from terminal A to terminal B, when you applied what? 1 volt. This is all about what? Ohm. 1 ohm is the resistance offered by that particular material when 1 ampere of current is flowing from terminal A to terminal B with what? With 1 volt of, with 1 volt applied voltage. Okay, so this is 1 volt by 1 ampere.